Daniel Walker. Our project is called Encrypted Messaging, even though the bigger basis of our project was to get the Nexus 2 board to communicate with the PIC development board using UART, and the encryption was actually kind of like a joke. We did the simplest encryption possible, which was we either added one to the value to encrypt it or subtracted one to the value to decrypt it. That is proprietary, so don't go sharing that.
The idea for our project was we wanted the Nexus 2 board to handle all the input and display information, and we wanted the actual PIC to talk to the Nexus board and the PIC to do all the encrypting and decrypting. So our requirements were one of the microblaze will communicate with the keyboard via UART. Keyboard entries and output from the PIC will be displayed on the LCD. Microblaze and PIC will communicate via UART, and the data sent to the PIC will be preceded by a flag to encrypt or decrypt the phrase and the length of the phrase.
And then the data from the microblaze being sent back to the PIC would be preceded by a flag stating whether or not it was the information was decrypted or encrypted and the length of that phrase. And then the PIC will use a simple addition subtraction algorithm to encrypt and decrypt the information.
Here's basically just an overview of the hardware structure that we use. Entering via keyboard to the Nexus board. The Nexus displays the entries from the keyboard on the LCD. At the same time, sends it over to the PIC to be encrypted or decrypted. And the PIC does its thing, sends it back to the Nexus board, and the Nexus displays the phrase from the PIC onto the LCD.
Our system block diagram looks pretty much the same as everybody else's. Only difference is we use two UART Lite intellectual cores to connect one to the keyboard and one to the PIC, and we use the general GPIO to connect to the LCD display. Our software flow diagrams, we had two separate sets of software running, one on the PIC and one on the microblaze. On the microblaze, we have it pretty much, it waits until you input a string and displays that string onto, or that phrase onto the LCD screen. It waits for the user to press F1 so that we can control when it sends the data to the microblaze. Sends the phrase to be encrypted, waits to receive that phrase back from the PIC, displays it, waits for the user to press F2 to send it back to be decrypted, and then waits for the PIC to send it to return the information and display it on the LCD again. On the PIC, we wait for a transmission from the Nexus board. We read the flag to determine whether or not we want to decrypt or encrypt the flag. We read in the length of the string, and then we encrypt or decrypt the string accordingly and send the phrase back to the Nexus board.
And so, for our integration and testing, we were able to interface the keyboard with the microblaze successfully. The UART on the microblaze was successfully implemented. The UART on the PIC was successfully implemented. So we were able to talk between the computer and the PIC. And
so we were able to get the Nexus to output an appropriate signal, UART signal, the exact transmission that we wanted it to. Unfortunately, on the receive line for the PIC, for some reason it was being held high, and we couldn't push it low enough. We tried using CMOS buffers to push it low and sharing the ground between the boards and the VDD between the boards, but it still would only drop the voltage from 3.3 volts to 2.3 volts, thus invalidating any signal. And then we also tried it with using a BJT to force it down, but that also didn't work. However, we were able to get the UART on the PIC board to work correctly with the regular computer interface via USB. So it's a little discouraging, but at the same time, it was an interesting challenge. Any questions? Any questions maybe about the PIC technology or anything like that?
What your demo consist of what?
Our demo will consist of us showing that we got the transceive line on the PIC to send data to the Nexus board, and then we can also show that we can communicate with the PIC board via the computer. We can also show that we can talk to the Nexus board with the keyboard. 3 separate parts. You can choose, you can show all of them. Yeah, it was a very frustrating challenge. We spent days trying to figure it out. Does anybody have any ideas on how to solve the problem? Yeah. Okay. So we'll go ahead and